Hello and welcome to this Python Bootcamp. I'm going to take you through all the basics of learning Python. I'm going to assume that you don't know anything about programming. So if you do know about programming and you're learning this because you just want to learn Python, please bear with everybody who doesn't know the basics of programming. Okay, let's get started. Now you don't have to install anything to do this bootcamp. I'm using here the Raspberry Pi Foundation editor. You just go to any browser and go to editor.raspberrypi.org. You can see the URL at the top. And if you type that in, you should get a screen probably similar to this. It might be different in the future if you're watching this. And I'm just going to click on the Python one here. You can sign in and have an account if you want to, but you don't have to have an account in order to use this website, and it will be free forever. So here is the interface for this editor. I'm just going to take you through this very briefly. We have this central part here. This is where we're going to write our code. We're going to click the run button to run our code, and any text output that we have is going to go here on the text output. You don't have to worry too much about this section here. Like I said though, you can sign up, get an account, and you can save your files and come back to them another time. Okay, so let's start programming. And the first thing that we're going to do is we're going to learn how to print to the screen. This is really important because when we get into doing more complicated things, being able to see what your program's doing and print to the screen is going to really help you. So I've just adjusted my screen so that we just ignore the files on the side because we don't need them. So I'm going to click on main.py here, and I'm going to type the word print, all lowercase, open brackets, and then hello world. And this is a rite of passage. Writing hello world is always the first program that you should really do in any language. So all lowercase. So important things here. Python is case sensitive. You must copy exactly what I type in order for the code to run correctly. Now the way that print works, it just prints to your text output. In this case, it's on the browser, and it's just printed everything that I've put in those quotes. So it's very similar to if you were doing speech marks in, writing a story, someone spoke something and you're quoting them, it's in quote marks. So literally anything that we do in this and we're printing to the screen has to be in those quotes. So please copy this code, and if you have an error, I'll show you some common errors that you might have, but just copy the code that I do and always try and remember to do it exactly as I've got. Programming languages have something called syntax, and syntax means that you must get everything right. So it means, it's a bit like grammar or punctuation in any language. You've got to get it correct. So we can do a similar thing. We can just practice print again. We can print anything in there. We can also print numbers. So I'm just going to print 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's just printed that on the next line. So we can use print as many times as we like in our code. And it is, like I said, going to be very, very handy. So pause the video and try this. Just try a few print lines. So common mistakes when you're doing print is you could, for example, leave off a bracket. So I've just deleted a bracket there on the hello world. And if I run this, you'll see I've got a syntax error and it's telling me what is wrong. So if you do have this red error, look and see what it's saying and look at the line of code that it tells you is going wrong, because this is going to help you figure out what's wrong. And it does say opening bracket was never closed on line 1 of main.py. Main.py is our file here. So I can see there that I'm missing a bracket and I just put that in and then it runs again. Another problem, like I said, is the quotes. You might miss the quotes. So if I take a quotes off at the end here, they're never closed. So again, it's telling us unterminated string literal on line 3. So it's telling me the line and it said you have not closed that quote. So try not to be scared by the syntax errors. They're there to help you figure out what's wrong. And coding is really picky. Python is not the only language where it has to have everything exact as it's expected, otherwise it won't work. And try not to get angry with it. It is easy to sometimes, but just try and go over your code. You have to have attention to detail when you're programming. Okay, so the next thing that we're going to do is we're going to look at something called variables. And variables are data stores in our program. When we're doing any kind of program at all in any language, really what we're doing is we're just manipulating data. And we're just looking at that data and thinking, what are we doing with it? We might change it, we might process it, we might amend it. And variables store that data. And you'll see what I mean as we go through. But the first thing we're going to do is we're going to look at the 4 basic types of variables. And the first basic type of a variable is an integer. And that's a whole number. So I'm going to create a variable. When you create a variable, you have to give it a name. So I'm just going to call it myInt, all lowercase. Remember, it's case sensitive Python. And I'm just going to give it a whole number like 99. So this is an integer variable, a whole number. The next type of variable is called a float. So I'm going to call it myFloat, and I'm going to give that a number 3.14, which is pi. And you can see it's got a number with a decimal place. Now, the reason why these are separate is because the way that computers store numbers is whole numbers are really easy for computers to store, but numbers with decimal places, they're actually quite hard. They have to do a little bit of processing, and so it's easier if you know you're going to have a whole number, just keep it as an integer, and it will make the life of the programming language quicker. It will make your code quicker as well. The next type of variable is a string, and a string is just any character in quotes. You can even have numbers, but I'm just going to put my hello world back there. Very similar, it's in quotes, just like speech marks. And a string variable is, yeah, you can have numbers in it as well. So we could put, for example, string world 999. You can even have just 999 on its own. That is still a string. It's not a number. It's a string because it's in quotes. And that's a really important thing to remember, but I'll mention it again. So that's my hello world. And then the last one is a Boolean, and a Boolean is true or false. And it's a capital T in Python for true, or you can have it as false with a capital F. And these are incredibly helpful variables to use in lots of aspects of programming. Very, very important. It's up to you whether you create it true or false, or set it to be true or false. It's up to you. So those of you who've done other programming languages, Python doesn't make you say which type your variable is. It will just create it as that type when you create the variable. So you don't have to declare it in any way. Now that we've looked at those basic variables, I'm just going to give you one extra handy tip, something called comments. The hashtag, it's not anything to do with hashtags on social media. Hashtag anything after a hashtag is ignored by Python. So this is a great way to document your code or add comments into your code to sort of say, this is an integer. So you can put it on the same line here. So I could put this is an integer, and it will ignore absolutely everything after that hashtag. Incredibly helpful, and I will be using these a lot more. So remember, if I'm going too fast for you, just pause the video and copy the code. Do keep all the code, by the way. Don't delete it. It's always a good idea to keep code so that you can refer back to it. Okay, so we've done variables. Let's now look at input. We need to get the user to type in some data. So let's look at input. That's what it does. Input. But we need a variable for input. So what I'm going to do is I'm going to just create a variable, and I'm going to call it user input, all lowercase. So there's my variable, and I'm going to type the word input, open brackets, and then a little prompt. You don't have to put a prompt, but I'll put enter your name, and then that's my line of code to get user input. And if I run this, you'll see it says enter your name. So I could type in anything that I want and then press enter, and that will be captured in that variable. Let's have a little bit of a closer look at variables though. So now that we've got our string that has been entered by the user, we can use that because it's going to be stored in that variable user input. So if I print it out here, I'm just going to print, and I'm going to print, instead of in text like we had hello world, for example, we're going to just put user input. So that's the name of the variable that we just created, And what happens is when I type in Bobby again, it will get stored in the computer, in the RAM actually, user input, and we're going to print it out. So it should print out Bobby. So I'm going to press run again, and it waits until, by the way, if you use input, it will sit there and wait until you press whatever you're typing in and then press the enter key. So it's really waiting for that enter key. So if I type in Bobby again and I press the enter key, it's now printed out. That second black Bobby there is print. This line here, print user input. So the blue Bobby is what the user typed in, and the black Bobby is the user output, the print. One of the really useful things about all editors for coding, or they should have some kind of color coding. It's actually called pretty printing, and it is really helpful for you to see what's going on. So we can see that numbers are green, strings are red, and sort of command words are black. So we can use what we've done so far to get some input, print some things out. So instead of on line 9, I've got user input. I could put here, actually I can combine hello, comma, or just, sorry, hello, and then close the quotes and then a comma and then user input. Don't forget this comma here. This is really important. And if I run that, it prints out the word hello, and then it prints out what was in the variable, the user input. So obviously I can type anything here. I'm going to just enter another name, Freddie this time, and it prints hello Freddie. So pause the video, make sure you have got that working, and then we'll move on to the next concept. Now our next concept is just doing a little bit of maths. So computers were created to do maths originally. So let's just have a look at that first before we move on. So you can literally do any maths at all, like I said, but the main things that you want to do, subtraction, addition, division and multiplication, are really easy. So the first thing that we're going to do is just do some addition. We can create variables, or we can use what's called hard-coded values, so actual numbers, but we're going to use variables. So I'm going to create num1, and I'm going to set that to be 8, and then num2, and I'm going to set that to be 4. So again, copy this code, and then all I'm going to do is I'm going to do print num1 plus sign num2. And what that is going to do is it's going to add 8 plus 4, and it's going to print out the answer, which is 12. So try that yourself. And then we can basically change that plus sign there to a minus sign, and that will take 4 away from 8. We can do a multiplication. Now multiplication is the asterisk, so that you would probably, if you've written, you probably think that it's x, because x is normally times, but in a computer x could be a variable name because it's a letter, so we use the asterisk for multiplication. So if I run that, it's 32. And then also you can do division, and with division it's the forward slash. Remember the sort of the division that you might have used or learnt at school, where division is this sign here. That does not exist on the keyboard, so we don't use that, we use the forward slash. So again, I'm going to run that, and 8 divided by 4 is 2. And you'll notice there, actually, with division, we always get a real or a floating point number, a float. Remember, float has a decimal place, and that's on purpose. That's on purpose. So just try those. I'm just going to print them all again for you so you can see them. And we've got num1 plus num2. And there we go. There's our basic maths. There are a couple of other things that you can do as well. So you can also do to the power of. So if I do num1 and then it's asterisk asterisk, which is to the power of. So I'll just add a comment there, power of. So it's the first number to the power of the second number. There's also we can do the percent mark. Now the percent mark isn't a percentage, it's actually modulus. Modulus gives you the remainder of a division. So it's the first number divided by the second number, but it's the remainder that you get for modulus. And there's also integer division, and this is an interesting one because what it does is it doesn't give you any decimal place when you do the division. So it's division with an integer as the answer. So modulus gives you the remainder, whereas the integer division just gives you the amount. So 8 divided by 4 is 2. So you can see the difference. The division, normal division with 1 forward slash is 2.0, but 2, no 0.0, because there's no remainder, there's no decimal place. That is integer division. Now you might not need to know how to use these, but it is helpful to know. So there's still some other things that we need to look at maths wise. Let's have a look at that. I'm just going to delete this. You can keep your code because otherwise, or just store it somewhere if you want to copy and paste it. So the next thing that we're going to look at is evaluators. And these are really important, and these use booleans. So we're going to look to see, is a number greater than or less than? So I'm going to use those numbers actually. I'll use num1, but this time I'm going to set my first one to 100, and I'm going to set my second one equal to 50. And then I'm going to say print num1 greater than num2. And you'll see what it prints is a boolean, a true or a false. So effectively what you're saying, if you use the greater than, is num1 greater than num2? Well, num1 is 100, num2 is 50. So is 100 greater than 50? Yes, it is. So it prints true. We could try a similar thing, but this time we're going to say, is num1 less than num2? Well, we know already that num1 is not less than num2. 100 is not less than 50, and that will say false. So whenever you use an evaluator, greater than, less than, greater than or equal to, etc., you're going to get a true or a false value. And these are incredibly helpful in programming. Let's try a few others. So we've got, is num1 greater than or equal to num2? And is num1 less than or equal to num2? And just think, for this one, is num1 greater than or equal to? Either has to be true. Well, that's going to be true again, and the next one's going to be false. And obviously we can change the numbers, but the key thing is with the equals to, it's always or equal to. It's one or the other, and if either one of them is true, then it will print true. So I'll just add that on. That is greater than, less than, greater than or equal to, and then less than or equal to. There's a couple of other evaluators that are helpful. There is also equals to. So is num1, and it's double equals. Is num1 equal to num2? So is num1 the same as num2? Is 100 equal to 50? Well, that's going to be false. There we go, that one's false there, the last one. And then also we can do not equal to. And it is the exclamation mark equals num2. So that's going to be true, because num1 is not equal to num2. So you can pause the video and try a few different numbers. So all you have to do is change these numbers here. So if I put 50, for example, num1's 50, num2 50, that's going to change a lot of these. Is num1 greater than num2? No, they're the same. Is num1 less than num2? No, because they're the same. Is num1 greater than or equal to, and it's the or equal to here, well, that one's true, so the third one's true. That one's going to be true as well because it's equal to. And then again, is num1 equal to num2? Yes, it is, so that's true. And then is it not equal to? And that's false. So just, again, pause the video, try a few different numbers, just so you can remember these. Okay, so the next thing we're going to look at is if statements. Now, so far, all we've done is we've had lots of lines of code, and the way that the computer works and any programming language works is it starts off with line 1, it runs line 1, there's nothing to run there because it's a comment, it runs line 2, creates a variable and gives it 50, it runs line 3, creates another variable, gives it 50, there's nothing on line 4, runs line 5, then 6, then 7, etc. until it gets to line 11 here, it runs line 11 and it's run out of code, so it stops running. Now that's all very well, but most of the time when we have programs, the user or the person or anything that is run on a computer has choices. And maybe you'll have code that isn't going to be run and you're running a different bit of code. And this is where our choices are dealt with. It's called an if statement. Now, if statements are incredibly powerful and they can take a little bit of getting used to, but the key thing to remember is you're just trying to think, I want my user, or I want to make a choice in my code. I'm going to do one thing or another thing, or maybe I have a list of different things that I want to do, and the if statement is going to let you do that. So I'm going to create a variable. I'm just going to call it age. And I'm going to set it to be, I don't know, I'll set it to be 14, for example. Oh, by the way, the spaces here, you can have spaces between the variable name and the equals and the number. You don't have to. It's just preference as to which. The weird thing with Python is sometimes the spaces really matter and sometimes the spaces don't matter at all. So it's really up to you how you do it. I'm just going to just leave it like that with spaces. But yeah, it doesn't matter. You can see if I run that, it doesn't matter which one I do. It runs, there's no error. Okay, so I've created a variable and set it to be an integer, a whole number, and then I'm going to write an if statement. So just write the word if, so you can see that it's already trying to tell me what I want to do. And so I'm going to say if age is less than 18, then, and then I put a colon, which basically means then. Now, this has got a less than, so this is going to give us a true or a false. And that's the key thing with an if statement. With an if statement, you're basically saying if this thing is true, so we have this kind of test here, if this test is true, then we run the code underneath it. But only if that is true. If the test here is true, then the code underneath it will run. So I'm going to add some code, and you'll see actually that when I press enter, so I wrote the code there with the colon, when I press enter, it indented the code, and that's on purpose. So I'll talk about that in a moment, but I'm just going to put here, print, you are a child. So you can see here that there is a little bit of a gap, and the gap here is on purpose. This is called white space, and if you are a programmer in other programming languages, you might have used them where they have brackets, so sort of curly brackets in Java, for example, and that's the begin and the end of a block. And in Python, we don't use brackets like that. We actually use white space to indicate a block. And all that means is we've got this block of code where we're only going to run the code underneath the if statement if it's indented. So basically, any other code that I put here, if it's indented, is only going to get run if age is less than 18. If age is not less than 18, it will ignore all of this code here, and it could be lots and lots of code, and it will just move to the next line that's not indented. So it's like describing sort of blocks of code. So this is where it's really important that when you're copying my code here, that you really do copy absolutely everything that I've done, including the white space. And if you don't add that white space in, you will get errors. And I'll show you actually, I'll show you an error here. I've not got the white space. I'm going to run it and it says indentation error. So if you do get an indentation error, it means that you haven't indented your code. So indentation error expected, an indented block after the if statement on line 3. Or on line 3 on 4 of main. So basically it's telling you again, look at the error, gives you the line number, you haven't indented the code. So you can just press the tab key or you can press space. Some people say you should do 4 spaces. Some people you prefer tab. It doesn't matter which you do, just make sure it's indented. Okay, so if the person's age is less than 18, then it should print you are a child, and they are. But again, if I change that to 61, then it won't print anything. That's because it's checked here and it says if the variable age is less than 18, then print you are a child. So they're not, are they? It's 61, you're not a child. So that's our basic if statement, but we can add things to this if statement. But everything else is optional. You must start with the if, but you can have as well, you can just have a plain else. So here we can say if the age is less than 18, you are a child. I've typed else and then a colon, and then you can print you are an adult. So if I run this now, it prints you're an adult, whereas previously it didn't print anything at all. So again, the else is aligned with the if, the I and the E here are aligned, and the prints are both indented. And that's really important because if I remove that, I'll get an error again. So it's all about defining blocks of code to say, I only want you to run this code if this is true, otherwise print this here, which is in the else. And obviously I'm only using print statements, but you could have any lines of code under these if and else. Now, another interesting thing with else, or if else, sorry, this else is optional, but you can only ever have one else for every if. So you can't have else that and then you have another else. That's not allowed, as you'll see in a moment. Syntax error, doesn't like it on line 7. You can only have one else. Now, you can also have other things called an elif. So it could be that we're checking to see if their age is less than 18, you are a child, but you could put elif, so it's before the else, elif, and then we can test again. Elif age is greater than 67, we can print you are retirement age. So if I run this one, it still says you're an adult, but if I change that to be, I don't know, 70, for example, it will print you are retirement age. So what the elif does is it gives you another option if you want to check more than sort of one or two things, actually one or two. You've got 3 things to check. We could add another one in if I'm going to add that before. So I'm going to say under the if, elif age is greater than 100, then print out you are over 100. Actually, I'll put it greater than or equal to 100. So if I run that, you are over 100. And I changed the age there to 102. So elif, incredibly helpful. You can have as many elifs as you like, but only ever one if and one else per block of code. But there are things that you can do. For example, if we've got someone who's under 18 and they're a child, we can put what's called a nested if, and a nested if, we can put another if under here. So you can have an if within an if. So we can say, if the age is less than 4, then we could say, oh, actually less than 2, print you are a toddler. So if I change the age to 1, for example, I run that, it says you're a child, but also you're a toddler. So every time you create an if statement, if it's nested within another if, you can even have it under the elif as well. They are separate blocks of code, and you can have, if you want to, you can have an else here. You can have elifs as well. It's totally up to you. I'm just going to put this in here. I'll just put error, for example. But yeah, you can have as many nested ifs and elses as you like, as long as you stick to the rules. One if, or sorry, for every if there is as many elifs as you like, but only one else per if, and you can nest them as much as you like. Now we're going to look at loops. There's two loops in Python, a for loop and a while loop. Let's look at for loops first. All loops do is let you repeat code over and over, and a for loop will let you repeat code for a set number of times. So if you know exactly how many times you're going to loop, maybe you're counting, you have an exact number, then a for loop is perfect for that. They're also perfect to use with arrays, but we'll come to that later on. Now, the way that we construct the for loop is we use the keyword for, then we have a variable. I'm going to use the word counter, and this variable keeps account of how many times you've looped. So if you're going to loop 10 times, it will start with, in fact, it starts with 0, or usually it starts with 0 anyway, and then it will go up to however many times you tell it. So then we need to use in range. All in range does is it says, okay, if I want to loop 10 times, start with either 1 or 0, and then go up to the range which I tell you, which could be 10, for example. So that's all it's for. Then we put a colon because we're defining a block of code. Again, it's indented under that for loop. And you can see that if I put any kind of code here, that it will run a set number of times. Now, we're going to tell it inside those brackets how many times we're going to loop. What you can do is you can have a starter number to start from. So say if I wanted to start with 1 and then I wanted to go up to 10. Actually, if I wanted to go up to 10, I have to put one more, which is 11, but I'll show you why that is in a minute. And all I could do, for example, is I could print out the counter. So the basic for loop is very, very simple and actually very powerful, because here I've got 2 lines of code to print out a number 10 times. And if I wanted to print out 1,000,000 times, I could still use 2 lines of code. So if I run this, you can see it's printed from 1 to 10. All it's doing is this counter variable. Like I said, it's an integer variable. It starts with the number that you give it here. That's the start value. And then the end value, in this case, it always has to be one more than you actually want to use. And that's just a quirk of Python. So just go with that. And we're just printing out that variable. So you can see we don't have to increase counter ourselves. Python does that for us. So it's a really good, powerful piece of code. Again, if I wanted to sort of go up to, I don't know, 100, I would just do actually one more than I want, 101. And if I run that, you can see it's gone up to 100. So just try that out. Try a few numbers. Obviously, if you do very, very high numbers with lots of zeros, then it's going to take quite some time to print that out. A couple of interesting things with a for loop is you can actually get it to step count. So you could have here, we could say, I just want to go up in 2s. So we add a third parameter or item into these brackets. And if I run that, you'll see it starts with 1, then goes to 3, 5, 7, 9, 11, until it gets to the closest it can to 100. In this case, that's 99. So again, try a few of these if you want to. You can go in the opposite direction, but I'm not going to cover that in the bootcamp. Another good thing that we can do with the for loop is, we can do things like writing lines. So we could say, okay, we've got to write 100 times for counter in range, and we're going to do it. You can start with 0 if you want to, but I'll start with 1 to 100. But obviously it's always one more than you want. And I'm just going to print, I must do my computer science homework. And then if I run that, it will print out, I must do my computer science homework 101 times. So again, really powerful, great for if you know exactly how many times you want to loop. So there are lots and lots of uses for for loops. They're incredibly powerful if you're using them with databases. You've got lots of data and you want to navigate around that data, with arrays especially as well. So again, always think to yourself, if I know exactly how many times I want to loop, or you can find out how many times you need to loop, then you always use a for loop. And it's always better to use a for loop if you can, because they're faster. Now our next loop, our second type of loop, is a while loop. And we can kind of view the while loop as a type of looping if statement. So previously when we did the code for the if and the else, we saw that we had, it just ran the code. It ran the if statement and then it just stopped. But sometimes you might need to repeat get that if statement. And so that's when you would use a while loop. So all a while loop is we have the keyword while, and then we have some kind of condition. So I've just put a placeholder here, and the condition is just a similar thing that you might have in the if statement. So for example, what we could do is we could say num, we'll input, num equals input, and we'll just put enter a number, or enter the number 100, while num is not equal to 100, and I'm going to put this in quotes actually. I'll put this in quotes because it's a string. Input always returns a string. Then I'm going to type here, while they haven't entered 100, then we're going to get them to enter the number again. So this is a great way to check user input actually. If a while loop's perfect for this. And then if they do enter that in, we're going to print out, well done, you entered 100. Okay, so let's just review this again. We're using input, which we've seen before. We're setting that to be whatever the user enters. Although we're asking them to enter the number 100, it's a string variable because that's what input returns. While the user, or while num is not equal to 100, then we're going to make them enter the number 100, and it will keep doing that until they enter 100. And then once they've done that, it will come out of the while loop and then run the next line of code. Remember, this is indented. Line number 4 must be indented because that num input enter number 100, that line is part of that while loop. We could add other things here if we wanted to. So we could have other code inside the while loop like that, but we're just having one line of code. So if I enter the number 100, so if I enter 99, it's now gone into the while loop and it's saying enter the number 100. So if I just keep entering different numbers that are not 100 until I enter 100, and then it will quit out because num was equal to 100. So a while loop we use when we don't know how many times we're going to loop. And that might be, for example, a user is doing something and there could be thousands of users who are all doing different things and we don't know how many times they're going to enter a number incorrectly or enter some text incorrectly. And so we use a while loop because they could enter it straight away, or it might be 50 times that they've done it incorrectly. Now, if you've done programming before, these are exactly the same as other programming languages. The for loop and the while loop are exactly the same. It's just, you just need to learn the Python syntax. So we've done our while loops, we've done our for loops. What we're going to look at now is arrays. Now, arrays are always defined by using square brackets. So always be careful when you're doing this part that you use the correct square brackets, find them on your keyboard. And what arrays do is they store variables in one kind of banner or umbrella. So for example, we could have class, actually not, I won't call it class, year 9 class, for example, and we're going to set that to be equal and we're going to add some names. I've used the square brackets and I'm just going to add in some names, for example, Sarah, Robert, Hannah, Freddie. I'll leave it at 4 for now, but you can see arrays are really good when you have data that is related to each other. So here is our array, and we can see that we've given it a label, just like we would give a variable a label, and we've set 4 different variables, and these are separate variables within the banner of the array, which is in square brackets. So we could print this out if you want to. So I'll just put print year 9 class, and it will just print out the contents of the array. And you can have numbers in your array as well. You can have any data type basically. So remember our 4 data types from earlier. We've got an integer, which is a whole number. We've got a float, which is a number with a decimal place. We've got a string, which is what we've got here. And you can also even have booleans as well. It's entirely up to you what you have in them. Now, just a note here that when I talk about arrays in Python, they're not actually called arrays, they're called lists. So if you are or you have experience of other programming languages, in Python, they are called lists, and in other languages, they are called arrays. Um, I mean, at this beginner stage, it doesn't really matter that I'm calling them arrays or one-dimensional arrays. But yeah, technically, if you do need help on them, then and you're Googling or you're going to ChatGPT and asking for help, you need to call it a list in Python. The only difference really is an array is usually a fixed amount. So if I created this in another language, for example, like Java, I couldn't add to it. I'd have to create a new array and then add items to it. It's a fixed amount. But in Python, you can add names to these. So let's have a look at that actually. We can add to this array. So I've got a new class person coming in. So I'm going to do year 9 class, and then I do a dot and then append. And for that, I'm just going to put in Gregory. He's the new student. And I'm just going to print that out again. And actually, I'll just copy that line there. And you can see that Gregory has been added on the end. So append, dot append, just you add something onto the end, always add it onto the end, and you can add as many as you like. That's basically what makes this a list in Python, because it means you can add things to it. We can take things away as well. So we can remove things. So I could put year 9 class dot remove, and I just want to remove, I don't know, Sarah. She's left, and we're going to remove her. We have to put the exact thing that we want to remove, and you can see there that Sarah's gone in that last print. There's lots of things that you can do with arrays, and you can actually also have 2D arrays. I'm not going to do that in this bootcamp, but they are incredibly powerful and helpful as well. Now, one of the key things with them though is how do we access different items? So for example, if I wanted to change Robert and change his name to Bobby instead of Robert, what would I do? Well, this is really important. We have what's called an index. Because each item in each array is a separate variable, we have what's called an index, and that gives us the position of an item in that array. So Sarah would be 0, Robert would be 1, Hannah is 2, and Freddie is 3. Now, you're probably thinking, why is it 0? Surely it should be 1. Yes, ordinarily, most things in real life, the first item in any kind of list or structure would be a 1. But in most programming languages, the first item in an array is usually a 0. There are a few languages that have it as 1, but Python is not unusual by having the first item in the index as a 0. And you just have to go with it. It is a little bit strange, a little bit weird, but just go with it, because yeah, like I said, most programming languages work like this. Going back to changing one of our items, we want to change Robert to Bobby. So we have to reference that directly. So we say year 9 class, open brackets, the number 1, because that's where Robert is. Robert is the first, or item number 1, not the first, but the item number 1. We reference it directly. We're not touching anything else in the array, and we just set that to be what we want it to be changed. And I'll just print that out again. And you can see that we've got Robert. Oh, I've changed the wrong one. Sorry, I've got it the wrong way around. I'm going to just put that before I remove Sarah. So there we go. I'll add it. There we go. If I do that the wrong way round, yeah, there we go. So now Robert is Bobby. And it changed previously before we removed Sarah. So try that out. Again, if I'm going too fast for you, just pause the video. This is a boot camp, so it is quite fast, but just pause the video and try everything out. And if you're getting errors, then always look at my code and think, what is different in my code to the code on the screen? And there will be probably something very subtle that's incorrect that you've done. Remember that Python is case sensitive. We use the square brackets around our arrays, and there's a comma in between each item of the array. So I mentioned earlier that for loops are great with arrays, and we can actually use a for loop to print out our array. What we can do is we can create a for loop. Actually, I'll do it up here so that we have I'll just delete that code. And I'm just going to print out everything in this array. So I'm going to use a for loop for, and this time instead of counter, I'm going to name my variable index. By the way, this variable here, you can call it anything. Most people though in programming call it index I or count or counter, something like that. Some people use X. I prefer either index or I. And then we're going to do in range. We start with a 0 and then a comma. And then what you can use is something called len. And what len does is it counts how many items are in your array. And that's how many times we need to loop. So this is why a for loop is perfect with an array, because we know, or we can find out how many times we need to loop. And we can use that in our for loop construction. So len, as I said, it will go to year class 9 array. And it will say how many items is in there. There's 4, even though it goes up to 3, there's 4 because we start with 0. So we can print out each item individually on a new line. So I'm going to print year 9 class, open square brackets, and then I'm going to put index. And what that does is it starts with Sarah, prints Sarah, then Robert, because index gets increased to 1. So when we run this line here, it increased to 1. It increases to 2, so it will print Hannah and then Freddie. And there we are, that's worked perfectly. So we can see actually that if we use inside our square brackets, instead of using a hard-coded number like 1 or 3 or 4, we can use a variable. So again, if I wanted to sort of change Robert to Bobby, what I can do is I can say year 9 class, open brackets, but actually I'm going to create a variable. I'm going to call it item, and I'm going to set that to be 1, which is where Robert is. And then instead of using 1, I'm going to use item, and that is going to be equal to Bobby. And what this does is instead of using, like I said, a hard-coded value, we're just using a variable. I just need to print that out, otherwise we won't see that it's worked. And there you can see that Robert is now Bobby. So there is, like I said, lots more to lists or arrays in Python, but this is just the boot camp, so we're just covering the basics. So the next thing that we're going to cover is functions and procedures. And this is an important aspect of any programming, not just in Python. And yeah, it works very similar way in most programming languages. Now, what a function and procedure is just a way of modularizing your code. You're going to look and think, have I got any code that I'm going to run over and over again? And that's a prime candidate to put in a function or a procedure. Now, there is a slight difference between a function and a procedure. The main difference is that a function will return something, it returns a value, and a procedure doesn't. Actually, you can return more than one value in a Python function, so a procedure does not return anything. So we have actually already used functions and procedures. We've used some library code functions and procedures. We used a function called input, where we were getting the user input earlier on, and that is a function because it returns what the user types in, so it's returning some values. We have also used a procedure, and a procedure that we've used is print, and print just goes away, runs some code, and then comes back. Now, there is lots of library functions and procedures in Python. We'll cover those in a bit, but let's have a look first of all at creating our own, because this is where things start to get really powerful in code. So in order to create a functional procedure, all you do is use the keyword def to define a function. We give that function a name. So for example, I'm going to do print welcome. And actually I'm going to use underscore print welcome. And then I'm going to have someone's name as, this is called a parameter. And I'll talk about those more in a minute. But then I'm just going to print a message. So I'm just going to print a whole load of asterisks in quotes, because it needs to be in quotes. And then I'm going to print a few more. No, actually, I'm just going to print the name, hello, and then name. And then I'm just going to print some more asterisks. Now, obviously, there's not much point to this function. Actually, it's a procedure. So I'll just put here that this is a procedure. But you can see the point of it is we might want to be able to run this code over and over again. Why? Don't know. But I press run and it doesn't do anything. Now, I haven't done anything wrong. The whole point of this is the def means define. So we're saying to Python, here is a procedure, and this is the code to run when someone calls that procedure. So you have to call the procedure in order for it to run the code. Remember, this is just the definition. It's not actually running the code. So in order to run it, all I do is I put print welcome, so the name of the functional procedure, and then I need to give it a name. So I could say Bobby, and that's my parameter. So that basically gets passed into name. And when it gets to this line here, line 6, it will print hello Bobby. So if I run that, you can see it prints hello Bobby. So if I change Bobby to something else like Donald, then it will print hello Donald. So I can print this again and I can do another one. So I could do print welcome Freddie, and it will run it twice, one with Donald, one with Freddie. So pause the video and practice this, because it is a really important aspect of any programming language, not just Python. And the whole point of this, like I said, is to cut down on repeated code, but also it lets you modularize your code and sort of create things that you can use over and over again in different scenarios. Now this is a procedure because it doesn't return anything, so we could create a function. So we could return a function or create a function, and I'm going to call it true or false. And I'm not going to, should I pass in a parameter? I'm not going to pass in a parameter, but I'm just going to create my function, and I'm going to say if, actually I'm going to create a variable called, actually, no, I am going to pass a variable. I'm just making this up as I go. So I'm going to pass in an age, and I'm going to say if age is greater than or equal to 18, then return true, else return false. Now, the interesting things about this is I've got parameters again. So I did add a parameter. This is my parameter age. It's going to be an integer. And what happens is when I call this, remember I'm just defining because I've used def to define. It will take that parameter. It will do an evaluation on that, whatever I've passed in. And then we've got this thing here, return. And what the return does is it says, whoever called me, I'm going to give you the value true. And this is, like I said, we've already used something kind of like this before, where it returns a value that is input. So let me just show you when I call this. So when I call a function rather than a procedure, you have to capture that return value. So what I'm going to do is I'm going to create one here, and I'm going to say is adult equals, true or false. And then I'm going to give it a value like 34. So that's someone's age. So you can see it's quite different calling a function to a procedure. There's a procedure, we just get it to run the code, but we have to capture the return for this in whatever we call, so I've called it is adult, and that's just a variable that it creates at that time. So it should print, if I print this out, print is adult, it should say true, and it does. So main thing, just be aware, is it a function, is it procedure? Ultimately, you know, it doesn't really matter. Sort of, is it a procedure or function, apart from when you call it, because you're thinking, do I need to capture whatever is being returned? And that's really the only reason why you would need to know. Now, there's a lot more to functions and procedures, and also the parameters. You can have functions and procedures with many different parameters in them, in those brackets. So you could have lots of them, literally as many as you want, but obviously you want to try and keep them to a minimum. Otherwise, you're probably making it too complicated. And you can also return more than one value. So you could here return an integer as well, you know, in which case you would have to capture it here. You would say is adult and then my num value as well. I would try and just stick to having one return value, especially as a beginner, because it just keeps it nice and simple. And I think it works out as better code if you try and just return one thing at a time. I think if you are returning more than one thing, one variable, then you're probably overcomplicating it. So the last thing that we're going to do is just have a look at some inbuilt functions. I mentioned not so long ago, there's lots of these. If you want to know all of them, do have a look at the Python documentation or online. We've already seen a few. So the first ones sort of we used were print and input. There's a number of different really helpful maths ones. So we could find the length of an array, or we could find the length of a string. So that is len, so len. And what length does, yeah, it finds how many characters or how many items are in an array. So for example, we could say length equals, and we can create, actually if I create an array, so I could say array equals 4, 5, I'm just giving it some different values. There we go. So the length is equal to len array, and that will just count how many items are in the array. And if we print that out, there's 7 in it. 1, 2, 3, 4, 5, 6, 7 is correct, yeah. We can do the same, we can use len as well for a string. So we could say my string equals hello, and we can just get the length for that one. Because a string is just an array of characters. So if we print out the length again, there's 5 in hello. Another useful function for maths is rounding numbers. So you might have a number with a lot of decimal places that you want to round. So we could have my float, and I'm just going to set it to be lots of different decimal places, and we want to round it. So we could do my float equals round. Then we give it my float again, and then you just tell it how many decimal places after the comma. So maybe we want 3 decimal places. And then if we print my float, then, it's forgotten to put an underscore there. There we go. And it's rounded it to 3 decimal places. So if you wanted to round it to 2 decimal places, you just put 2. if you want it to be rounded to 8 decimal places, it will round it to 8, etc. You can even do 0 decimal places as well. A couple of other common maths ones, you can use min or max. So, for example, you could have an array. Oh, we've got our array. We can find the minimum value in that array. So we could say min val equals min of my array. And if we print out min val, then it should print out the lowest one, which is 2. So yeah, 2 is the lowest value in that array. And we can do max as well. So we could do max val equals max array. And we print out max val. And that is 56. Yeah, that's correct. A couple of other string functions that are really helpful, making something all upper or lower case. So let me just get some space here. So we can make something all upper or lower case. So I'm just going to create my str or my string again, and I'm going to set that to be hello world. And then I'm going to make it all uppercase. So I do my string equals my string dot. I'll do it uppercase first. Stop upper, open close brackets. And then if I print out my string, and it's put it all uppercase. And I can do the same with lower. In fact, I'm just going to copy and paste that. And I'm going to put, instead of upper, I'm going to put lower. And you can see it's turned it all lowercase. So that's really helpful in a multitude of places. Okay, so that is the end of this bootcamp. I hope you found this helpful. It is just the beginning of Python. There's huge amounts more, but this will get you a long way to understanding and moving up to the next level of programming in Python.